All right, so here we're going to learn about the trig form of a vector, which I know you're like, wait, there's another form to represent a vector. Like, can't someone just pick a form? But again, remember, they're all essentially the same thing. It's just different ways to find the same exact thing. Component form and rectangular form are exactly the same thing. It's just a different way to write it. Trig form is a way to find those pieces of the components in component form and the scalars in rectangular form. This will be really important with our applications. So direction angles, we talked about this already. If u is a unit vector such that theta is the angle measured counterclockwise from the positive x-axis to u, then the terminal point of u lies on the unit circle. That should make sense because u is a unit vector, right? So u in component form, x comma y, can be written as cosine of theta comma sine of theta, or in rectangular form can be cosine theta I plus sine theta j. All of this should make sense because we know the coordinates on a unit circle are x, y, which are represented from the cosine of the angle or the sine of the angle, respectively. And this is just writing it in rectangular form. Again, theta is the direction angle of the vector. Okay, what if it's not on the unit circle? Not a problem. Same thing with anything in trig. When it's not directly on the unit circle, we can still treat it somewhat like it is. So if I have some vector v that is just any vector, v equals ai plus bj, and then I can write this in trig form as, in component form, it would be the magnitude of v times the component form cosine theta comma sine theta, or in rectangular form, it would be the magnitude of v times the cosine of theta I plus the magnitude of v times the sine of theta j. So really what we're getting at here is that A is going to be magnitude of v cosine theta, and B is going to be magnitude of v sine theta. So again, all this is just a different way to find the A and B pieces of the rectangular or component form of a vector. And again, this is going to be terribly useful in our applications that we're going to see here in a minute. This part we've already seen. How do I find theta? Well, I know tangent of theta is b over a. So we already saw that before when we learned how do we find the direction of a vector. But we also know from our knowledge of trig that we could represent this as tangent of theta is sine of theta over cosine of theta, or in terms of vectors, magnitude v sine theta over magnitude v cosine theta. Those would just reduce, obviously. Okay, so this is the new thing we want to make sure we understand from this video is how trig is going to apply to finding these pieces of the component and rectangular form of a vector in our applications, which we will see in the next video.